We used a pipette to add solution to the cuvette up to the line. Make sure to clean your station once you are done with your experiments. We used water as a blank in the spectrophotometer and put it in and press 0 on the computer to find the absorbance of clear substance so we could subtract that from our other solutions. We wiped 2 sides of the cuvette to make sure the spectrophotometer could read the visibility of the solution properly. We put the clean sides to the beam to make sure the light went through the substance in the cuvette completely. We close the spectrophotometer so that outside light doesn't affect the absorbance.
The Beer-Lambert law states that the absorbance of a material is directly proportional to its thickness. Its formula is A equals epsilon times L times C. A equals absorbance, which is determined by the multiplying epsilon, L, and C. C is the concentration, which is determined by using the formula M1 V1 equals M2 V2. By knowing M1 V1 and V2, you can isolate M2, the concentration. L is the length of the solution light passes through, and it is determined by the width of the cuvette. Epsilon is a molar absorptivity, and it is the measure of the probability of an electronic transition. The relationship between absorbance and concentration is linear. Failing to zero the machine would increase the absorbance value because you would not be calibrating the machine to take account to a clear substance.
For this lab, the solutions have to be diluted and absorbed at different wavelengths so enough energy is received by the detector and the different qualities in molecules can be properly observed. Another reason why you have to scan all wavelengths is so you can properly observe lambda max, which refers to the wavelength along the absorption spectrum where a substance has its strongest photon absorption, and compare it to that of the unknown.
We recorded across all wavelengths with our stock solution to find which wavelength would work best for all of our solutions. Once you're done finding the absorbance of a solution, carefully open the spectrophotometer and remove the cuvette so you don't spill any of it. We wrote down the optimal wavelength, 580 nanometers, in our notebook to make sure that we used it for all of our solutions.